Assalamualaikum, ma'am.
Walaikum salam. How are you, Amna?
Alhamdulillah, ma'am. How are you?
I'm fine, thank you. Hello, Aruba.
Hello, ma'am. Assalamualaikum.
Walaikum salam. How are you?
I'm good, ma'am. How are you?
I'm fine, thank you. Hello, Ahmed. Ahmed Farouk.
Yes, ma'am.
How are you?
I'm good, ma'am. Thank you so much for asking. How are you?
I'm fine, thank you.
Ma'am, I've tried sending you an email, but you haven't responded to that. I guess I went through a surgery, so I couldn't have attended few classes previously.
Ahmed Farouk, right? Ahmed Farouk,
Yes, ma'am.
I've not received any email from you. Where were you sending those emails?
Ma'am, I've tried getting your email from Moodle and sending an email twice on it. I don't know if you haven't received those.
What's the address? You don't know my email address? You can see it in Moodle.
Yes, ma'am. I took that from Moodle and I've sent it on that address.
Can you please tell me where exactly you've been sending it?
Yeah, ma'am. Give me a moment. Let me just check my email.
I think you've been sending to a wrong email.
Yes, ma'am. I guess so because I've even got something and sent mail that the email couldn't be sent.
Okay, so that means that you were sending to a wrong email. So in order to see my email, you can go to Moodle and you can look at the course outline. You will see my email there. Also, if you look at the recordings of the first class, for example, in this course, you will also, I gave my email to students at that time as well. Okay.
Okay, my bad, ma'am. I'll look into that and I'll send you the discharge slip again.
Okay, fine. So how are you now?
Ma'am, I'm really good. Thank you so much for asking.
So is this your first class?
Ma'am, I've took a class even before. Like in the beginning, I took one class. Then I went to operation. I couldn't have taken classes,
One class
and
on
now this is the
campus?
second class. Sorry.
You took one class on campus?
No, ma'am. Online.
Online, I don't have your attendance. This is your first attendance that I have.
Ma'am, I've just I just came in one class. There was a second class, I guess. I came here in that class, and now this is the second class I am in.
No,
Like
Ahmed
this is
Farouk,
my second class.
I've been marking the class attendance and I don't have your attendance in the online classes.
Ma'am, I have attended the second class. Maybe I have the screenshot as well because I sent it to one of my friends.
So you know that I did call out your name, so maybe you didn't respond. And normally I
Yes,
also
ma'am. I came for a while. Then I had to leave. So I just wrote
you came
you
for a very
that an email
short
as well.
time probably, and otherwise, of course, I do have the list of participants as well. Okay, right.
Exactly, ma'am. I came for a short time.
So did you give your assessments?
Yes, ma'am. I did.
Both assessments.
Ma'am, I've done a quiz like the one you uploaded. I haven't done anything else.
And what about the assignment?
Ma'am, I haven't submitted that.
Okay, so you missed the assignment, you've given the quiz. Now please prepare for the midterm examination. The assessment schedule is online. Look at your deadlines and plan properly. Okay.
Okay, ma'am.
Right. So I will go through the material that we have in Moodle, and then if you have a problem, you can tell me.
Thank you so much, ma'am.
Okay, now we're going to start. So let's see. So I'm sure all of you are refreshed after the holidays, right? And now we can start with chapter number 3. And chapter number 3, as you can see, about electricity. Okay.
Yes, ma'am.
So these are all, this is a very simple basic course, as you know. These are all concepts that you're already familiar with, and therefore we will discuss them and then we will do some assessments based on these, right? And of course, we remember to practice the practical material that I'm uploading every Thursday, just like we do during on-campus classes, and remember to follow that as well and practice it and prepare yourself for a lab exam as well. Okay, so talking about energy and electricity, you know, these are very important topics relevant to the present situation we have. And as you know, that Pakistan has been facing problems of energy and electricity. Rather, it's a global issue. So this is important and relevant, and we should understand it because it's something we use in our everyday life. It depends on it. So first of all, what is domestic energy and how our consumption has changed over time? But from the physics point of view, we'll be discussing more about the sources of energy that we have and the principles and concepts of physics that on which these energy sources are based. Then we can talk about our, of course, the usage of electricity, and then we'll come to some circuits, and again we'll discuss some laws that are relating to this. So when we talk about sources of energy, power sources, one of the major sources of energy we're using today are fossil fuels, although we know that there are many disadvantages, but we are still dependent on these in many ways, and we do have these sources. We are using petrol, for example, we're using hydrocarbons, we're using gas. So in this case, we are also using coal, although we know that coal again is not very environmental friendly. We do know that, but anyway, so this is something that we're still using. And the principle, of course, is the energy. As we know, one of the basic laws of physics is that energy can never be created or destroyed. It can only be converted from one form to another. So all of these energy sources are based on this basic concept. We have to find a source of energy. We have to find how to convert it to a form that we can then use. So a coal, for example, when you go through the process of combustion, for example, it is chemical energy, which is then converted into heat energy. And heat energy, you can see a diagram here that is showing this, and you can see that this heat energy is then converted into electrical energy with the help of turbines, as you know. And then this energy is distributed to cities and then or factories, and it can be used. So that's one way of generating energy. Another way of generating energy we know is nuclear power. Pakistan has nuclear power reactors, and again, this is based on on the principles of physics of how energy can be converted into you know, for example, it's the famous equation is equal to mc squared. We know about fission and we know about fusion. Nuclear reactors we're using in Pakistan are based on the concept of fission, and fusion is something for the future. It's something under research. We've not been able to commercialize it yet, but fission is something that has been developed over time, and we have many reactors in the world and in Pakistan as well. So nuclear again has its own advantages and disadvantages, but as physics students, we should understand, you know, there are a lot of myths and all that about it as well. So we should understand what it actually is. Again, talking about hydroelectric power, again, Pakistan depends on hydroelectric power, and hydroelectric power is the power we generate through dams, right? In this, again, we're using the principle of conversion of one form of energy to another form of energy. So you know that in a dam you store water, and when this water falls through a height, potential energy is then converted into mechanical energy, which then, you know, the rest of the diagram would be the similar, like you will have turbines that will convert that mechanical energy into electrical energy, and which becomes your electrical power. So again, these are some details relating to this. Hydropower, every source of energy has its advantages and disadvantages, and you should be able to understand that. So for example, there are some points written about this over here. You can go through them. And then this is again an example of tidal power. Tidal power again is another source of energy. We know that we have tides wherever we have, for example, the sea, and this power can also be utilized to generate electricity. Another form of electrical power source can be wind turbines, and wind turbines, of course, use the principle of the wind turning the something like a windmill, and this mechanical motion is then converted into electrical energy and can be used. Again, this is something that cannot be done everywhere. There are certain geographical locations where we have a suitable wind velocity and wind conditions that can lead to such generation of energy. And this is also known as
मैम मैम it's आमना प्लीज जो इवेंट पावर से पहले वाला था टाइडल पावर वो दोबारा बता दो, उसकी समझ नहीं आई.
टाइडल. आपको पता है टाइड किसको कहते हैं? व्हाट इज अ टाइड?
नो मैम.
समुंदर की लहर मैम, साउंड फाकर.
Okay, good. So tides are related to the rising and falling of the surface of water. It may be the sea or the ocean, and this is due to the attraction between the moon and the sun and so on, right? So when these tides, whenever water, जब इसकी waves बनती हैं, tides बनती हैं, it carries energy, ठीक है? और उस energy को there are mechanisms to convert it into electrical energy, ठीक है? क्या नाम था? आमना?
Yes मैम.
Okay, good. So then we have solar power. Again, this is something I'm sure all of you are familiar with. The word solar relates to the sun, as we know, and we have many solar panels also that are commercially available. So this is something you can do on a smaller scale, like for your home, or you can do it on a larger scale, like you can make a solar farm. So this is known as a very good source of energy because it's renewable. It does not produce carbon dioxide. It's good for the environment. And then people are working on this to improve this so that it can be commercially economically viable, and people can increase the percentage of solar power that can be used in our homes and in our cities, and maybe also in our factories. Okay, so then another source of energy we know is geothermal energy. The word thermal means
Heat.
Yeah, thermal is related to heat, and geo is related to
The earth.
yes, the
Earth.
Yes. So geo is related to, it can be related to geology, it can be related to the earth. So we know that there are certain places in the earth that that produce heat by natural mechanisms, and this heat, we know that heat is a form of energy, and this heat can then be converted into electrical power, and then they can be used. Of course, geothermal steam, for example, this we know that coal also is burnt or combusted to make steam and then power. This was the first source of energy that was used during the first industrial revolution, and then now we're finding new sources of energy based on new concepts, or basically most of these concepts are coming from physics. Each of these, again, remember that energy, each of these concepts of energy or each of these sources of energy do have their advantages and disadvantages, and we cannot rely on one source only. So we normally talk about energy strategy for a country or a place based on a pie. It should contain a certain percentage of renewables, it should contain a certain percentage of other sources in order to ensure a stable and environmentally friendly source of energy. We cannot depend on one particular source of energy, no matter how good it may be. And then, of course, we have also to look at the economical and the technical viability. And like many of these sources also depend on the geographical conditions. For example, solar energy, as you know, there are certain places where you have more sun exposure, and there are certain places where you cannot have it. But again, solar is something that does not work 24/7. So you have to have alternate sources that can, that can work during the time that solar is not available, for example. The same goes for wind. Wind is something that we cannot utilize everywhere, but there are some places you can look at. There are maps in Pakistan, for example, where the places that are suitable for solar energy, places that are suitable for wind energy, and so on. Okay, and then you also have to have some other backup source, so that of course we cannot, that if there's a power failure, it affects everything in our life. So we cannot rely completely on one source of energy, and we should have a good combination of these sources of energy. After energy and electrical power, one of the important topics that you are all familiar with are electrical circuits and electric charge. So these are electrical circuits are something that you're using every day in your life. All the devices that you're using have some kind of a circuit in them, right? And electrical circuits are based on the flow of electric charge. So again, we'll look at these concepts. Electric charge unit is the Coulomb. So Coulomb was a scientist, and this is the unit, and the symbol is C. Okay, so electric field, whenever there's a charge, charges can be positive or they can be negative. We have positive charge and we have negative charge. And whenever there's a charge, we know that around that space you can experience a certain electric field. So the region in which you can experience the strength of this charge is known as the electric field, because if a charge is placed in this field, it will experience attraction or repulsion. And this electric field is defined by E is equal to F over Q, where E here represents electric field, F is the force experienced by the charge, and Q is the symbol for charge. So Q is the small q. Remember that small q, capital Q are different, and you have to follow the conventions that we have. So small q is the symbol that we are using for charge, capital F is the symbol we're using for force, and capital E is the symbol we're using for electric field. And of course, the units in this case, we know that the unit for force experienced, would be newtons, and per charge, newtons per coulomb, right? And electric current is another important term that we have to understand when we are talking about electrical circuits. We know that in all our devices, we have electrical current, the flow of current. And what is electrical current? Current is defined as the flow of charge. So whenever charge is flowing, there is electrical. So what you're doing when you're connecting a wire, charges are flowing through that wire, and this flow of charges leads to electrical current that then helps you run the devices and the equipments that you have in your homes, offices, factories, everywhere. So again, the units for electrical current are amperes. The symbol for ampere is capital A, and 1 ampere is equal to 1 coulomb per second. So 1 ampere is equal to a unit charge flowing per unit time. So it means that current is equal to charge per unit time. So these are very small and simple concepts. Again, we know that current can be direct. We have direct current, right? And we have alternating current. You are familiar with the concept. Direct current is called DC, and alternating current is called AC. So current direct means that the net flow of charge carriers are moving in one direction. Alternating current means that the charge carriers are moving in alternate directions, right? It can be upwards and downwards, or backwards and forwards, and so on periodically. So these are some terminologies related to these concepts. Another concept that we use whenever we are working, and you're all familiar with this, you're using these devices every day, you're charging your devices, you're switching them on, you're switching them off, you're connecting wires, which means you're making circuits, or you're using circuits, right? And these are small circuits that you can also make in the use in the lab, right? So electric potential difference, this is another term. Electric potential difference in everyday life is known as voltage. Now, you know that whenever you buy a charger, you look at the voltage, for example, right? So every process needs a certain amount of voltage, in order to carry it out. So a voltage between 2 points is defined as the change in potential energy per unit charge moving from one point to the another. So since potential energy is a form of energy, your potential energy, we have the gravitational potential energy that we talked about in the case of the hydroelectric dam, for example. you know, when something is at a height and it falls down, it has potential energy, right? But then in electrical context also, we do have the concept of potential energy. When charge is moved from one point to another, there is a certain potential energy. So therefore, the units of energy we know are joules, which is capital J being the symbol. So when this is moving per unit charge, then joules per coulomb is defined as a volt. The symbol for volt is V, capital V, and the symbol for voltage is also capital V. Okay. Right, so potential difference changes at different points around the circuit. We can look at that later on when we discuss circuits in detail. And then we also have a concept of conductors and insulators when we talk about electrical circuits and electrical power. So what are conductors and what are insulators? Yes?
Ma'am, conductors are
नाम
those
बताया करो
who
पहले.
Amna.
Amna, yes Amna.
मैम कंडक्टर्स वो होते हैं जो इलेक्ट्रिसिटी जिनसे पास कर सकती है और इंसुलेटर्स वो होते हैं जिनसे इलेक्ट्रिसिटी पास नहीं कर सकती.
Okay, and example?
Ma'am, metals are conductors and wood is insulator.
Okay, so for example, your wires are made of?
Ma'am, they are made of any metal like copper or zinc.
They're mostly
So
made of
they are,
copper, right? So
yes, ma'am.
a material that is conducting that will transport it, but you cannot touch the wire because
Copper.
you will get an electrical shock. So if you have to touch, you would touch with an insulator like wood or rubber.
Like
Yeah.
rubber and plastic.
Okay, now there's an important relationship between resistance. Resistance, again, you know, whenever there's a circuit, there is a resistance. So resistance to the flow of charge, and this is defined as voltage divided by current. Now you can play, this is a very simple small law, and you can play with it. You can say I is equal to V over R, or you could say V is equal to IR. So you can have small problems based on this simple formula. And again, these are some, you can calculate, make some calculations, you know, taking into account length, area, temperature, material, and so on. Okay, so we just talked about electrical charge, we talked about the units, we talked about the forces. We know that Coulomb's law, according to Coulomb's law, we know that charges attract or repel each other, right? And this attraction or repulsion is based on the magnitude of, you know, this is a simple concept, like charges repel and unlike charges attract each other. So if we have two charges, let us say Q1 and Q2, they will experience a certain force, and this force will be directly proportional to the product of the charges and inversely proportional to the distance between the charges, and this is known as Coulomb's law. And we just talked about electrical fields, so you can read about this. This is an explanation of the concept of electrical field. And then we can talk about, so again, these are some diagrams that illustrate this concept. If you have a charge, you have a certain region where you can experience this force, and this region is called the electric field, and these lines represent that electric field, and these lines have a certain direction as well. So you have these points that can again illustrate this. Field lines, there are some conventions, like for example, these lines begin at positive charge and end on negative charge. Okay, so they're pointing towards the negative charge. Field lines are not supposed to cross or split, so they are, you can see none of these lines are crossing each other. And field lines that are close together represent strong fields, and field lines that are separated represent a weak field. And a charge placed in the field experiences a force in a direction along the field. So this is an illustration of the concept. Of course, in reality, you don't see lines, but in order to understand it, we've made a geometrical representation of this concept. Again, these are some diagrams that illustrate the concept of an electric field. You can see this here. You can see that you can have, for example, a negative charge and all the lines are pointing towards it. And if you have a positive charge, the lines are pointing away from it, just like we just discussed. And then these are different diagrams that show different arrangements of these charges and how the lines of force will be drawn. So these are called electric field maps. We talked about electric field strength. We talked about E is equal to F over Q. So we can also use this formula to make small calculations to understand and solve problems, right? So again, we talked about electric potential, which was voltage, and this is also defined in terms of work done. We know that in normally we define work as force multiplied by displacement. Previously, we were discussing about mechanical work, where you carry something and take it to another point, and that is work. But then electric, in the electric concept also, force into displacement means force using the formula E is equal to F over Q. We have that the force is equal to the electric field multiplied by the charge. So we can substitute this for force and then multiply by displacement, and we get the formula for the work done, because an electric charge is also doing work when it is moving. And this work is then defined in terms of the voltage, as we can see. And this is what we also call the potential difference between 2 points. You always need a potential difference for electric current to flow. You know that you always have to connect a source of voltage. That can be either a battery, it can be a cell, it can be your the AC source that we're using. So we always need a potential difference for charges to flow. We talked about current. As I just said, the symbol for current is I, and this is defined as the charge flowing per unit time, and the unit in this case is amperes here. I've already talked about this, but again, you know that whenever you're buying a charger or a device, you know that the current is also written on it, the voltage is written on it, the power is written on it. So normally an ampere is a large unit, and sometimes you need a small current, and therefore milliampere or microampere can be small units that you might find on your device. All of this is written in any device that you may have. Direct current, alternate current, if you want to represent it graphically, you will see that if you plot a graph between time and current, direct current will be represented going in one direction. But if you have alternating current, you will see that the direction of the current will change back and forth. Okay. Now, this is an example of electrical circuit and how charge is flowing through this circuit. You can see that this is the symbol for a battery. A long line and a short line is a symbol for a battery, and the long line represents positive charge, the short line represents negative charge. This A with a circle is the symbol for an ammeter, and you can see the flow of charge is represented with these arrows. Now, conventionally, convention means something that has been scientifically accepted, internationally. The convention is that the direction of current is considered to flow from positive to negative. Although, because initially people thought that this was the way charge was flowing, later on they found that current is actually the flow of electrons, which flow in the opposite direction. But we still use the same convention, and that's how we mark or label our circuit diagrams. Okay. And then we have that current can flow in different kinds of materials, and then the conductors, insulator concept as well that we've just talked about. And of course, the concept of atoms and molecules that every material contains, batteries and cells, we've talked about this. The symbol for a battery, we've talked about this. EMF and voltage, voltage is also, there's a potential difference, for example, of 1 volt across a battery if a coulomb of charge is given 1 joule of potential energy. So that's another definition we come across. And the instrument used for measuring voltage is called a voltmeter, just like ammeter is an instrument used for measuring current. So here this is important. You can see the symbols for all the different kinds of components we use in an electrical circuit. This is the battery. This is one cell, and if you have more cells, you can use more than one cells in a device. So this is represented like this. A voltmeter being the instrument for measuring voltage. A resistor can be represented like this or this, and then this is a variable resistance, for example, with an arrow that can be changed. And then ammeter, we've talked about it. Switch, you always have a switch in an electrical circuit. This is a bulb, and this is a capacitor. Okay, let me take your attendance now. Okay, so Ahmed Hassan, absent. Fahad Ahmer, Fahad bin Ahmer, no, he's not there. Aisha Ahmed, we have many Ahmeds in this class. So Hafiza Aisha Ahmed, she's not with us. Musa, Sayyid Muhammad Musa, Ali Musa, no, he's not with us. Mahnur Amjad,
Present, ma'am.
okay. Nimra Arif,
Present, ma'am.
Nimra, okay, yes, I can see your name. Okay, Sayyid Azad Asad, he's not with us. Farooq Ahmed Farooq, yes. Okay. And okay. So Awais Gill, he's not here. And Laiba,
Yes, ma'am.
present. Sahib Khan,
Present, ma'am.
Elia Shafqat,
Present, ma'am.
good. Amna Maham,
Present, ma'am.
good. Nashra Rashid,
Present, ma'am.
good. Aruba Riyaz,
Present, ma'am.
Halima Ijaz,
Yes, ma'am. Present.
Nawab Siddiq. Nawab is not there. Sumavi Tahir, she's not there. And Saud Rafaqat.
Present, ma'am.
Okay, so now, of course, your homework is to go home and revise the
Ma'am, you
chapters.
didn't call my name.
What's your name?
Ma'am, Ahmed Farooq.
Farooq, I called your name.
Ma'am, you didn't, maybe I didn't listen that.
Acha, it's okay. I've marked your attendance.
Thank you, ma'am.
Okay, so now we know there's a small law that I've just mentioned, which is known as the Ohm's Law. So according to this law, we know that we have a small formula where V is equal to IR. So you can write this law in different forms and you can solve small problems using this law. We just discussed this formula, V is equal to IR. So if you have two quantities, you can find the third quantity. So it's based on the voltage, the current, and the resistance. And again, why do we have resistance in insulators, for example? This is an explanation of how this concept is dependent on, for example, the length, the area, and so on. And there's a parameter called the resistivity rho of a material. So you can go through this. The unit of resistance is called an ohm, and its symbol is omega. So this is a Greek symbol. Rho is the unit of resistivity in this case. And resistivity is defined from this formula. So resistivity is different than resistance. The symbol for resistance is capital R. Resistivity is rho. So this is resistance. Okay. So please again, you revise and prepare for your midterm also. Prepare chapter number 2. Chapter number 1, I think all of you have prepared it because we had the assignment and the quiz from chapter number 1. But chapter number 2 is also coming in the midterm examination. So your homework will be to prepare chapter 1 plus 2 for midterm. You know the date of the midterm exam is given in Moodle. It's given in, it has been discussed several times. So please prepare for this and also revise what we have studied today relating to chapter 3. And today is Wednesday. On Thursday, I will upload the practical material. So regularly every week, spend 1 or 2 hours on preparing your practical material, because in the end, you will have a lab exam as well. As 15% of the weightage of this course is the lab exam. That's why it's a 4 credit course. So practice the lab material. Lab material is uploaded every week, and just like in normal classes, you have a lab every Thursday for 2 hours, 2 p.m. to 4 p.m. So now I would like you to spend this time every Thursday to study, prepare, and practice the lab material that is uploaded every week. Remember to do this. Don't leave it to the end, because then you will be confused. Also remember that the lab practicals, the experiments, are based on concepts that you're studying in these classes, in this theory, in these chapters. So doing those experiments virtually, although we're doing it at the moment, I've also given you the links where you can do these virtual experiments, and this will help clarify the concepts we are studying in class as well. So this is very important. So remember your homework, okay? Right?
Yeah.
Okay,
Yes,
good. So when you make circuits in the lab, like you will also see in the experiments you do virtually, or whether you do them virtually or physically, you will see that you use small resistances. These resistances, as we just saw, the symbol is sometimes like this, and sometimes it's given like this. These, when you look at them in the lab, they look like this, and you see they're color coded. And these different colors correspond to different values of resistances. And I've also uploaded some material. You will see it where you can interpret the value of the resistance based on these colors. So you can look into that. These are some circuits that we will be solving later on. For example, we can solve one maybe right now, although we don't have much time. So if we look at this, for example, okay, so if we look at this one, let's look at this one, or let's go to the beginning. Wait. We have this circuit in which we have a resistance of 10 ohms and a voltage of 12. And the question is, what is the reading on the voltmeter? So how will you explain this? Or what is the reading on the ammeter? Who can answer this question? Can you try to answer this question?
Ma'am,
Who is speaking? You will get a point for this. Yes.
फॉर्मूला लगा के जो गिवन
नाम बताओ.
साउल रफाकत.
साउल, फॉर्मूला बताओ.
मैम इन दोनों को मल्टीप्लाई कर देंगे.
बेटा फॉर्मूला बताओ.
मैम आमना मैं फॉर्मूला बताऊं?
हाँ बताओ.
वोल्ट इज इक्वल्स टू आई, वी इज इक्वल्स टू आई आर.
अब वैल्यू बताओ.
मैम वी 10.
वी 10 है. 10 क्या है? ओम.
ओम इज इक्वल्स टू आई और आर का है 12 वी.
ये आमना ने सही बताया है. अच्छा मेरे पास अब टाइम, ये मीटिंग एंड होने वाली है, ये गलत है, इसमें गलती है, ये हम नेक्स्ट टाइम डिस्कस कर सकते हैं. आप सब लोगों का ये होमवर्क है, इसमें देखो गलती क्या है. ओके, आमना से एक छोटी सी मिस्टेक हो गई है. ठीक है.
ओके मैम.
हाँ, तो आप लोग therefore nobody gets a point so far because we have not there was a little mistake in this, so ये mistake next time मुझे बतानी कैसे correct करनी है, ठीक है?
ठीक हो
Okay, ma'am.
So revise your work, do your homework, and we'll meet on Friday. Okay? Thursday वाला काम आपने online करना है.
Okay, ma'am.
Okay. Take care.
मैम
Yes. कौन बोल रहा है?
साउल रफाकत
Peace out.
मैम जो थर्सडे वाले दिन आप हमें जो वो भेजती हैं वो होमवर्क वाली शीट लैब की वो हमें फिल करके सबमिट करवानी है या बस पढ़नी है और